So this integral here looks intimidating, but don't worry, I promise we're gonna solve it. So first of all, let's make a use up here of negative ln of x equal to a u. That will make the dx equal to negative e to the negative u du. And as to the bounds, whenever x goes to 0, u is gonna approach negative of the negative infinity, which is infinity with the positive sign in front of it, and whenever x goes to 1, u is going to be a 0, perfect. Our integral then becomes this integral from infinity to 0, quite weirdly, of sine of negative u over negative u times negative e to the negative u du. Okay, so now I would like to use that negative sign in front of the du to flip those bounds of integration there. And now just notice that sine of negative u is negative sine of u, sine is an odd function. I can cancel out the negative in the numerator and the denominator and get this nicer looking integral from 0 to infinity of the sine of u over u e to the negative u du. And well, I would like to get rid of this u in the denominator. Honestly, I mean, it just messes up with everything. I can't use integration by parts now, I can do anything. So, I would like to evoke the Feynman trick now. I would like to place the parameter somewhere in this integral, and I would actually like to do it inside of the exponential. I'd like to multiply that negative u in the power of the e by my parameter, let's call it a maybe, and then my entire integral just becomes a function of the parameter I of a. And the specific I of a, the specific I care for is I of 1. Yeah, so I evaluated at a equal to 1. Awesome. Now, I would like to go on and differentiate both sides with respect to the parameter a. Yeah, so I will get this integral of the partial derivative of this entire thing, but well, sine of u over u is just a constant, nothing of a there. And then times the derivative of this e to the negative a times u, which is negative u times e to the negative a times u. Love it, because this u, this negative u, cancels out with the u in the denominator, and I get just the integral of this negative sine of u times e to the negative a times u du. But that's something I can deal with using integration by parts, but because it's boring as hell, I'm gonna just skip it and give you the answer right now. You just have to, play the integration by parts twice there and kind of mess around with those terms, but it's, boring. So that's what you get. If you plug in those bounds of integration, you will get this thing. And don't worry about that cosine and sine and infinity. I mean, that exponential with this negative sign just drags down everything to 0. No problem there. So we get that this derivative of our I of a with respect to a is this negative 1 over 1 plus a squared. Okay. Well, now I could just go on and integrate everything here indefinitely with respect to the a and get that, I of a is this negative arctangent of a plus c. But I don't want to do it because I will get that plus c, which I don't want to look out for, honestly. There is an easier way to solve it. Well, I would like to use definite integrals here. So what are gonna be my bounds of integration if I'm to integrate this derivative of I of a? Well, I know that I'm looking for the value of I of 1. That's exactly the integral I'm looking for there. Yeah, that's awesome. So I'm just gonna say that the upper bound is gonna be 1. And also, I know one more thing. Let's evoke the original definition of my function I of a once again. So we know that I of 0 is just, well, this integral, which is the Dirichlet integral evaluating to pi by 2, because, well, it's rather half of the Dirichlet integral. I love it, because if I place the lower bound, if I place 0 in the lower bound of this integral, I will know that it's all gonna evaluate to I of 1, which is the integral that I'm looking for, minus pi by 2. Awesome, because I also know that I can actually evaluate the left-hand side is gonna be the negative arctangent between 1 and 0, or the 0 and 1. So negative pi by 4 minus 0 is equal to I of 1 minus pi by 2. And so I of 1 is negative pi by 4 plus pi by 2, so positive pi by 4. And that's our answer. Hope you guys enjoyed it and see you in the next one. Bye.